Hello, everybody. Today we're going to be taking a look at one of my favorite areas of geometry, trigonometry. So trig. Today you're going to need a scientific calculator, something to write with, and your notes. So make sure that you have those handy, especially that foldable that we made in class. You may have heard of trigonometry, and it kind of sounds a little scary, but I promise it's something that's really cool and applied in a lot of different areas in sciences and math, and I think you're going to find it's very useful as we go through the rest of the year. So trigonometry, you don't need to write this part down, but basically it's Greek for measurements of triangles. So we're going to be focusing on finding missing measurements in triangles. And our work is going to focus mainly on right triangles. So again, the Pythagorean theorem is helpful, but I have to have two pieces of that triangle to find a missing leg or a missing hypotenuse. And this way, I don't have to have those same amount of information. We'll be using new buttons on our calculator. So make sure that you find these three buttons, sine, cosine, and tangent. On scientific calculators or on your phone calculator, make sure that you have located those three buttons. They will be our go-to. On my phone calculator, sine, cosine, and tangent. On a scientific calculator, they will be right there. Also, you're going to want to make sure that your calculator is set in degree mode. That means that it knows that your angles are measured in degrees. This one's showing radians right here because it says RAD, and this one too. So if your calculator's not set in the right mode, you can usually change that. On the scientific one, it's right there. That changes it from degrees to radians and vice versa. On the phone calculators, I'd have to take a look at yours, but you can maybe sort of figure it out. Here's a DEG button right here that maybe might be the clue into turning that thing into degree mode. But we're going to want to make sure that's happening, especially when you get to your work later to come. So you should have your foldable, and we wrote down already some of the basics about these three ratios, sine, cosine, and tangent. You've made this in class. These are three ratios that we're going to use to find missing sides in triangles. When I open up my little foldable like this is what he looks like. You maybe already drew these pictures in, or you may need to draw that right now, depending on if you've done this already. And we're going to be setting up the three ratios based on those facts that we have written in there. This fact for sine says sine of the angle, and the angle is always an acute angle, ladies and gentlemen. The sine of the angle equals opposite side over the hypotenuse of my triangle. So let's use this triangle over here on the left to sort of set up some fractions based on an acute angle that we're standing at. So one of the acute angles in the triangle would be angle A. He's not 90, he's not obtuse, he's acute. So we could set up the sine for angle A. The sine ratio for angle A says that you take the opposite side. So if I look where I'm standing, I'm up here at angle A right here. Which side would be opposite me? It would be this 5. It's labeled with a 5. So I'll use the 5, that's opposite. And then the bottom part of the ratio or the fraction says hypotenuse. What number would be the hypotenuse in this triangle? That would be 13 because it's across from the 90 degrees and it's the longest side of the triangle. So the sine fraction for angle A is 5 over 13. Now, is this the sine fraction for all other acute angles? Nope. Let's pretend that we move down here to angle B now. If I was going to do the sine of angle B, that means I might be located in a different spot in my triangle, so the opposite side might be different. If I'm here, the side opposite me is across from me here. He's now a 12. The hypotenuse is still 13, so my sine fraction for angle B is 12 over 13. So this is just the basic idea of how we set up those ratios. As you can see, it depends on where you're standing. It depends on that acute angle. And so when we do this example over here on the right now, let's look at our triangle and say, what acute angle are we given? That's right, it's the 16. This is a 16-degree angle that we are given. That means that we need to set up our ratio based on standing at that 16 degrees, based on understanding that this is where we are located right now. So the sine ratio says sine of the angle equals opposite over hypotenuse. So the sine of the angle that I'm standing at, what angle are we standing at? That's 16 degrees. Equals opposite side. Which side would be opposite us if we were at that 16-degree angle? That would be the 7. And then the hypotenuse of the triangle is labeled with an x. So it says sine of 16 equals 7 over x. I need to solve this for x now, and here's where your calculator comes in. And we're going to be doing some cross multiplying here. We have one fraction on the right-hand side. Let's go ahead and make this guy a fraction over here. So I have sine of 16 over 1 equals 7 over x. Now I would go to my calculator and ask my calculator to give me a decimal approximation for the sine of 16. So you type in sine 16 in your calculator, and it gives you kind of a crazy answer here. 2756, and a lot more happening after that. I always like to keep 4 decimal places for accuracy at this point. And then now we just take a look at what we have, and we want to cross multiply here, guys, to solve for x. So if I cross multiply this way, I would get 7. And if I cross multiply the other way, I would get 0.2756 times x, which is 0.2756x. And now to get the x alone, here he is, we need to divide by that 0.2756 so that I find that x equals 25.4 approximately, okay? So there's my value for that missing side of that triangle. It's very important that you keep 4 decimal places when you type in sine, cosine, or tangent, because we don't want to round too much and then round again at the end. Let's take a look at another one of those ratios. This one's different. Cosine. Cosine ratio says cosine of the angle equals adjacent over hypotenuse. Adjacent is a word we haven't seen for a while. Adjacent means next to or touching that angle, okay? So when we set up these fractions, let's go ahead and do it again for the a and the b. Cosine of A means that I'm standing up here at an angle A, and I need to set up the cosine fraction, which says I'm going to put the adjacent side. The adjacent side would be next to it. Now there are 2 sides next to it, 12, 13. Well, 13 is the hypotenuse. I can't use him twice. So 13 is going to go on the bottom because he's the hypotenuse of the triangle. That means the adjacent side is going to be the 12. So the cosine of A is 12 over 13. Let's do B. Cosine of angle B. If I'm down here at B and I set up this fraction down here, adjacent over hypotenuse, if I'm here at angle B, my adjacent side is going to be the 5. And then the hypotenuse remains 13. So again, location of that angle and where you're at determines what's adjacent to you. So when we look at our example on the other side, what acute angle are we given? 42. Notice that we're given this 42-degree angle, and we notice also that it's adjacent to an x, and the 18 is a hypotenuse. So if I go ahead and set up my cosine fraction, it would say cosine. Then after that, we put the angle. Cosine 42 equals adjacent side, x, over hypotenuse side, 18. So if I solve this again, remembering that we want to put this over 1 so we can cross multiply, I'll go to my calculator and get a funny decimal for cosine of 42. 0.7431 over 1 equals x over 18. And then we'll go ahead and cross multiply again. 1 times x is just x. And 18 times that decimal we got would give me 13.4 approximately for that missing side. So it says x equals 13.4. So I'm done solving for x on this one. Let's do the third one. So we have a tangent fraction. Tangent of angle equals opposite over adjacent. So again, those same words are coming up. We need to set up those fractions based on an acute angle. So let's pretend again, first one, we're starting here at angle A. So let's set up the tangent fraction for A. If I'm at A, angle A up here, and I need to do the opposite side, opposite me would be 5. And adjacent to me would be next to me, which would be this 12. So the tangent of angle A is 5 over 12, or 5/12. Now let's switch locations. Now let's be at angle B. Let me put my pen back. Now we'll go to angle B right here. So the tangent, if we're at B, is opposite, that'd be 12, over adjacent. Careful, the 13's the hypotenuse in this triangle. We're not going to use them. There's no hypotenuse in here. So 12 over 5. Nice. So our two fractions are set up there. So let's go ahead and do another example like we were doing, using these ratios to find the x. So let's look at this picture here. We're given this acute angle of 24. So let's pretend we're standing at the 24. If I look across from the 24, I see that this is my opposite side and 15 is my adjacent side. Notice I don't have anything on my hypotenuse, so I know all I need is opposite and adjacent. So I'll go ahead and set up this tangent fraction ratio here according to the setup that we have written on the left-hand side. So tangent, angle A, or angle B, in this case, the angle is 24, given to us in the picture. And then opposite is x, and then adjacent is 15. And now we go to our handy-dandy calculating device. Tangent, 24, is 0.4452. And again, I want that over 1, so I can cross multiply with my other fraction over here. And so we'll go ahead and cross multiply here, this way and this way, and we end up with 1 times x is just x, and 15 times the funny decimal is 6.6768, depending on how you round it there, okay? So that's how we use these ratios to find missing sides when we can't do the Pythagorean theorem. Let's look at one more here. Write this in your notes underneath your foldable. This time we have an x and a y in the same problem. So notice it's always about that angle that we're given. Which acute angle are we given in this triangle? The 48. So we're going to pretend that we are standing in right here, this location in our triangle. Let's pretend I want to solve for x first. That means I'm just going to ignore the y for right now. So you can put your hand over the y or whatever you need to do, but we're only going to focus on finding what x is. Notice that relative to the 48 that's given to us, x would be opposite me. And the other number that I actually know in the picture is 8. And I would say that 8 is my adjacent side. Okay, opposite, adjacent, and hypotenuse are my only 3 choices for labels here. And so 8 has to be my adjacent side. So if I'm solving for x, I need to use one of the ratios that has opposite and adjacent in it. And that one is tangent. So I'm going to set up the tangent ratio. So it says tangent 48 equals opposite over adjacent. And now I have something that I can go ahead and solve. So I'll use my calculator. Tangent of 48 is 1.1106 equals x over 8. And I'm going to stick this one over 1 so I can cross multiply. So I'd end up with 1x equals, and the answer would be 8.88, 8.9, depending on how the directions ask us to round. So that's what the x value is, okay? So now let's take a look at how would we find y. Well, for the y, I don't want to put x in that problem. I'm going to focus on this y right here. Y is on the hypotenuse. And again, remember 8 was adjacent to where we were, the 48 degrees. And so I'm going to set up one of those ratios that has an adjacent and a hypotenuse in it. That one is cosine. So cosine of 48 equals adjacent over hypotenuse. And again, I'm going to use that calculator. Cosine of 48 is 0.6691 equals 8 over y. Put this over 1 so we can cross multiply. 1 times 8 is 8. Funny decimal times y is just 0.6691y. And notice the y is not alone after we cross multiplied. I have to do one more step here. I'll have to divide by that funny decimal to get the y alone, and I'd end up with 8 divided by 0.6691, which gives me a value for y of about 11.96, or if I had to round to the nearest tenth, I'd call it 12.0. Okay, so that's my y value, and there's my x value. We found 2 answers, and we chose which ratio we wanted to set up based by what we were looking for and also what we were given. So this will be our work for the coming days to figure out what do I set up and then how do I do the math to find that extra y. So thank you for taking good notes, guys, and I'll see you later.